at 12,800 feet above sea level on Bolivia's Altiplano, where the air is so thin that modern visitors gasp for breath with minimal exertion, where oxygen levels hover at 60% of what sea level dwellers consider normal, where even walking feels like running a marathon, sits a collection of stone blocks, whose precision defies everything we think we understand about ancient construction capabilities. These aren't rough-hewn boulders stacked by patient laborers using simple tools, aren't crudely shaped monuments testifying to determination, overcoming technological limitations, aren't the products of trial and error learning by cultures gradually developing construction skills. These are machined surfaces showing tolerances of 1/10 of a millimeter, perfectly flat planes that modern engineers recognize as requiring sophisticated equipment, right angles so precise that trying to replicate them with hand tools produces only crude approximations that highlight how impossibly accurate the originals are. Puma Punku, the gateway of the Puma in the Aymara language, represents perhaps archaeology's most troubling puzzle, the site that conventional explanations struggle to address, the monument that forces uncomfortable questions about what ancient peoples could accomplish and what technologies they might have possessed that history hasn't preserved. The stones aren't simply impressive in size, though some weigh over 130 tons and would challenge modern cranes operating at this altitude. They're impressive in their precision, in their uniformity, in their mathematical exactness that suggests manufacturing processes rather than hand carving, that implies template-based production rather than individual artisan work, that demonstrates capabilities matching or exceeding what modern stone cutting achieves using diamond-tipped rotary tools and computer-guided equipment. The measurements tell the story that visual inspection suggests but that instruments confirm beyond dispute. Surface flatness varies by less than 0.1 millimeters across spans of several feet, creates planes so perfect that trying to detect irregularities requires precision tools rather than simple observation, demonstrates control over stone cutting that shouldn't exist using copper chisels and stone hammers that conventional archaeology insists were the only tools available. The right angles aren't approximately 90 degrees, aren't close enough for Bronze Age work, are exactly 90 degrees, within tolerances that modern carpentry considers acceptable, that metalworking shops achieve routinely, but that hand-carving stone simply cannot replicate regardless of how skilled the artisan or how patient the work. The joints between blocks mock modern attempts at understanding how they were achieved, fit so tightly that inserting razor blades between stones is impossible, create seams invisible except where different stone colors meet and reveal that separate pieces have been joined. The precision isn't random, isn't occasional achievement in particularly important locations, characterizes the entire site uniformly, suggesting systematic capability rather than exceptional individual efforts, implying production methods that maintained quality across all work rather than techniques that succeeded only when conditions were perfect and craftsmen were especially skilled. Every block shows similar precision, every surface exhibits comparable flatness, every angle demonstrates identical accuracy, creating pattern indicating template-based manufacturing rather than custom handwork. Modern engineers examining Puma Punku express confusion, admit that replicating this precision using period-appropriate tools hasn't succeeded despite multiple attempts, acknowledge that achieving such accuracy requires capabilities that conventional chronology insists didn't exist when the site was supposedly constructed around 500 to 600 AD according to mainstream dating. The engineers aren't easily impressed, have experience with sophisticated manufacturing, understand what precision requires in terms of equipment and methodology, recognize when they're seeing capabilities that exceed what available technology should enable. Their confusion isn't polite skepticism about native intelligence or ancient determination, is genuine bewilderment about how specific results were accomplished given constraints that evidence indicates applied. The stone material adds another layer to the mystery, compounds the impossibility that precision measurements reveal, ensures that conventional tool explanations fail before addressing how uniform surfaces were achieved. The blocks are carved from andesite, a volcanic rock registering 7 on Mohs hardness scale, harder than any copper tools that could cut it, harder than bronze implements that weren't available in South America during period when mainstream chronology places Puma Punku's construction hard enough that working it requires either harder materials like corundum or diamond or alternative methods like ultrasonic machining that modern industry developed only recently. Copper measures 3.5 on Mohs scale, bronze reaches perhaps 4.5, neither approaches the 7 that andesite achieves, meaning that conventional tools would wear away faster than the stone they were supposedly cutting, would dull immediately on contact, would prove useless for any sustained work, much less for creating the thousands of precise surfaces that Puma Punku displays. The implications are straightforward, are unavoidable for anyone accepting physical evidence at face value, are revolutionary for understanding of what ancient cultures knew and what capabilities they possessed that orthodox archaeology hasn't acknowledged. Either the builders had access to materials harder than andesite, had diamond-tipped tools or corundum abrasives or something equivalent that evidence hasn't preserved and that no archaeological excavation has recovered despite extensive work at the site, or they employed alternative methods that didn't require harder materials, methods that modern industry recognizes as possible like ultrasonic cutting or high-precision water jets or techniques that we haven't developed because conventional materials work adequately for contemporary purposes. Neither possibility fits comfortably with conventional narrative about Bronze Age cultures using simple tools, about indigenous South Americans working with limited technology, about human societies developing capabilities gradually through incremental improvements rather than possessing sophisticated knowledge that later periods lost. The H-blocks, those distinctive interlocking stones that resemble manufactured components more than hand-carved monuments, epitomize Puma Punku's precision, puzzle, demonstrate capabilities that defy conventional explanation more dramatically than simple flat surfaces or accurate angles could. The blocks feature complex three-dimensional profiles, incorporate multiple planes meeting at exact angles, include precisely cut grooves and channels that interlock with complementary shapes on other blocks, create modular system where components can be assembled in various configurations while maintaining perfect fit regardless of arrangement. The complexity isn't decorative, isn't aesthetic choice, serves structural function enabling construction methods that conventional stone architecture doesn't employ, suggests engineering thinking rather than artistic expression, implies purposes requiring precision assembly rather than merely impressive appearance. The standardization troubles analysts as much as precision does, indicates manufacturing approach that Bronze Age cultures supposedly didn't use, implies production methods generating identical components rather than custom fitting each stone to specific location. Multiple H-blocks show identical dimensions within measurement tolerance, can be exchanged for each other without affecting structural integrity, demonstrate interchangeability that modern manufacturing considers essential but that ancient construction supposedly achieved through patient hand-fitting of unique pieces. If the blocks are truly interchangeable, if they were produced to templates ensuring uniformity, if manufacturing process maintained tolerances enabling any block to serve in any compatible position, then Puma Punku represents production facility rather than construction site, implies centralized manufacturing of standardized components that were then assembled into structures whose purposes remain mysterious, because so little of original configuration survives. The drill holes scattered throughout the site present their own impossibilities, their own evidence of capabilities exceeding what conventional tools should achieve, their own testimony to knowledge that orthodox archaeology struggles to explain. The holes are perfectly circular, maintain uniform diameter from entrance to exit, show no wandering or deviation that hand drilling inevitably produces, demonstrate control suggesting mechanical guidance rather than human steadiness even when drilling through multiple feet of andesite. Some holes pass through several inches of stone without varying diameter by measurable amount, create cylinders so uniform that modern machinists would approve their quality, prove that whoever created them understood how to maintain alignment and control pressure and generate rotation sufficient to cut through material harder than their tools. The absence of construction debris compounds the mystery, adds another impossibility to collection of features that conventional interpretation can't adequately address, removes evidence that might explain methodology if it existed. Cutting thousands of tons of stone produces waste, generates dust and chips and fragments that accumulate around work areas, creates debris fields that archaeologists normally use for understanding construction techniques and dating occupation periods. Puma Punku shows none of this, exhibits cleanliness suggesting either that debris was meticulously removed after work completed or that stone processing occurred elsewhere and finished components were transported to the site for assembly. Either explanation raises questions that conventional archaeology prefers not confronting about organizational sophistication, about production methods, about capabilities that don't fit comfortable narratives about ancient technical limitations. Standing among the blocks, touching surfaces that shouldn't be so smooth, running fingers along edges that shouldn't be so sharp, examining joints that shouldn't fit so tightly, visitors confront evidence that words struggle to convey, that photographs inadequately capture, that direct physical examination makes undeniable. This wasn't achieved with copper chisels and stone hammers, wasn't produced through patient handwork and tribal determination, wasn't result of simple technology applied skillfully over extended time. This required capabilities that modern equipment replicates but ancient tools supposedly couldn't approach, demonstrated knowledge that later periods, lost or never recorded, proved that assumptions about technological development proceeding gradually, from crude to sophisticated might be wrong because Puma Punku exists, because its precision is measurable, because no amount of theoretical explanation alters physical reality that these stones present to anyone willing to examine them. Without preconceptions about what ancient peoples could or couldn't accomplish at altitudes where breathing is difficult and where conventional archaeology insists that Bronze Age cultures worked miracles using tools that physics says shouldn't work, that experiments demonstrate don't work, that honest assessment acknowledges couldn't produce what stands weathered but still precise on Bolivia's Altiplano, where questions accumulate faster than answers and where every measurement deepens mysteries rather than resolving them. The H-blocks represent Puma Punku's most troubling puzzle, the architectural elements that defy conventional explanation most dramatically, the stones that force uncomfortable questions about manufacturing capabilities that Bronze Age cultures supposedly didn't possess. These distinctive components, named for their H-shaped profile when viewed from above, weigh approximately 600 kilograms each, measure roughly 1 meter in height, demonstrate precision that modern machinists recognize as requiring sophisticated equipment rather than hand tools. The blocks are carved from andesite, that volcanic rock registering 7 on Mohs hardness scale, harder than any copper or bronze tools that could shape it, requiring either diamond-tipped equipment or alternative cutting methods that conventional archaeology struggles to explain. Yet the surfaces are perfectly flat, the edges are precisely defined, the corners meet at exact 90-degree angles, both internally and externally, creating geometric perfection that hand carving simply cannot achieve regardless of skill or patience. What makes the H-blocks truly remarkable isn't just their individual precision but their standardization, their interchangeability, their uniformity, suggesting template-based manufacturing rather than custom hand-carving of unique pieces. Recent measurements reveal that multiple H-blocks are practically identical, show dimensions matching within tolerances that modern manufacturing considers acceptable, demonstrate consistency indicating production process maintaining quality control across multiple units rather than artisans creating custom pieces through trial and error. The three-dimensional complexity of H-block profiles compounds the mystery, adds layers of impossibility to already troubling precision. The blocks feature multiple planes meeting at exact angles, incorporate precisely cut grooves and channels creating interlocking geometry, include internal right angles that conventional stone carving tools shouldn't produce, demonstrate capabilities that suggest mechanical guidance rather than freehand work even by master craftsmen working under ideal conditions. The interlocking design serves structural function, enables assembly methods where blocks connect through geometric rather than gravitational means, creates systems where components lock together through precise fit rather than relying on mortar or weight to maintain stability. The grooves cut into block faces match complementary projections on other blocks, form three-dimensional puzzles where pieces can only fit in specific orientations, require precision manufacturing ensuring that mating surfaces align perfectly despite complex geometry involving multiple planes and angles. Modern engineers examining the H-blocks express bewilderment about production methods, acknowledge that achieving such precision using period-appropriate tools seems impossible, admit that replicating these components would require computer-guided equipment or extensive hand finishing that would consume time and resources far exceeding what ancient construction supposedly involved. The precision isn't approximate, isn't close enough for Bronze Age work, meets standards that contemporary manufacturing considers acceptable for metal components, exceeds what stoneworking typically achieves even with modern diamond tools. The surfaces exhibit flatness varying by less than 1/10 of a millimeter across spans measuring several feet, create planes, so perfect that detecting irregularities requires precision measurement instruments rather than visual inspection, demonstrate control suggesting mechanical rather than manual production. Running a straight edge across H-block surfaces reveals no gaps, no high points, no variations that hand carving inevitably introduces, proves that whoever made these components understood how to achieve and maintain flatness exceeding what conventional tools enable. The right angles meet at exactly 90 degrees within measurement tolerance, show no deviation that would indicate approximate handwork, demonstrate accuracy matching what modern carpentry considers acceptable, prove that ancient manufacturers possessed either instruments for verifying angles or production methods that automatically generated correct geometry without requiring constant measurement and adjustment. Checking corners with precision squares reveals perfect fit, no gaps, no deviations, geometric exactness that hand tools shouldn't produce. The internal angles, those 90-degree corners inside the H-profile where perpendicular surfaces meet, present even greater challenges than external geometry, require cutting methods that can reach confined spaces while maintaining precision, demand capabilities that conventional stone carving struggles to explain. Creating internal right angles in hard stone using copper chisels would dull tools immediately, would generate frustrating slow progress, would produce rounded rather than sharp corners because soft tools can't maintain crisp geometry when working harder materials. Yet the H-blocks show sharp internal corners, demonstrate precise angles in confined spaces, prove that production methods could access tight geometry while maintaining accuracy, suggest either that tools were harder than the stone they cut or that alternative methods avoided direct mechanical contact between tool and workpiece. Ultrasonic machining, water jet cutting, chemical etching, all represent modern approaches that could produce such results, yet attributing these technologies to Bronze Age Bolivia strains credibility unless one accepts that ancient knowledge exceeded what conventional chronology admits. The drill holes piercing H-blocks add another impossibility, demonstrate capabilities that hand drilling shouldn't achieve, provide evidence that production involved more than simple tools applied patiently. The holes are perfectly circular, maintain uniform diameter throughout their depth, show no wandering that manual drilling inevitably produces, prove that guidance systems maintained alignment ensuring that drill bits traveled straight paths through stone harder than the copper tools supposedly creating them. Some H-blocks feature multiple drill holes arranged in patterns, positioned with geometric precision suggesting template-guided placement, demonstrating manufacturing consistency that handwork doesn't achieve. The holes aren't randomly located, aren't casually placed, follow precise layouts indicating either that measurements determine positions or that templates ensured uniformity across multiple blocks, implying production sophistication that Bronze Age cultures supposedly lacked. The absence of construction debris around Puma Punku, that mysterious lack of waste material that stone cutting inevitably generates, suggests that H blocks weren't manufactured on-site, implies that production occurred elsewhere and finished components were transported to the plateau for assembly. If blocks were produced at distant manufacturing facility, if standardization enabled interchangeable parts, if ancient builders employed production methods separating manufacturing from construction, then organizational sophistication exceeded what conventional archaeology attributes to indigenous South American cultures. The H blocks scattered across Puma Punku today represent fragments of larger structure, broken pieces of architectural system whose original configuration remains mysterious because so little survives intact. The blocks aren't positioned functionally, aren't assembled into recognizable structures, lie scattered as though catastrophe disrupted original construction, suggest that whatever event destroyed Puma Punku was violent enough to break apart precisely fitted components, forceful enough to scatter blocks weighing hundreds of kilograms across the site. Yet despite breakage, despite whatever forces shattered original structure, the H blocks retain their precision, still demonstrate geometric exactness that shouldn't exist, continue testifying to capabilities that conventional explanation struggles to address. The broken edges reveal internal structure, show that blocks are solid stone rather than faced surfaces over inferior cores, prove that precision extends throughout material rather than being limited to visible surfaces, demonstrate that manufacturing standards applied to entire components rather than merely to portions that would be exposed in final assembly. Standing among scattered H blocks, examining surfaces that shouldn't be so flat, measuring angles that shouldn't be so precise, contemplating manufacturing methods that shouldn't produce such results, visitors confront evidence that challenges comfortable assumptions, that forces questions about what ancient peoples could accomplish, that suggests capabilities exceeding what orthodox archaeology acknowledges. These blocks weren't hand-carved by patient artisans using simple tools. They represent manufacturing achievement, demonstrate production capabilities, prove that someone possessed knowledge that later periods lost. The blocks scattered across Puma Punku didn't originate from the plateau itself, weren't carved from bedrock convenient to the construction site, came instead from quarries located vast distances away across terrain that would challenge modern transportation, much less ancient methods that conventional archaeology insists relied on human muscle power and simple tools. The red sandstone blocks, those massive components weighing up to 131 metric tons according to engineering estimates, traveled approximately 10 kilometers from quarries near Lake Titicaca, a distance that seems modest until one considers the weight involved and the complete absence of wheeled vehicles or draft animals in pre-Columbian South America. The andesite blocks, those precision-cut stones showing the most impressive machining qualities, originated even farther away, came from quarries located on the Copacabana Peninsula roughly 90 kilometers distant across Lake Titicaca's waters, required either overland transport, through mountainous terrain or waterborne shipping across the lake followed by final overland movement up to the plateau. Either route presented challenges that modern logistics would require careful planning to overcome, that contemporary equipment would struggle to accomplish efficiently, that ancient methods supposedly based on rope and human labor seem inadequately equipped to handle. The conventional explanation proposes that blocks were moved using log rollers, rope, and coordinated teams of workers pulling, in unison, methods that experimental archaeology has demonstrated can move heavy stones given sufficient time, personnel, and ideal conditions. This explanation works adequately for blocks weighing several tons, becomes challenging but possible for stones reaching 10 or 20 tons, starts straining credibility when masses exceed 50 tons, and breaks down completely when confronted with 131-ton components that require forces exceeding what even large teams using optimal techniques can generate. The mathematics are straightforward, reflect basic physics that doesn't change regardless of cultural determination or spiritual motivation. Moving a 131-ton block across level ground requires overcoming friction that even with log rollers beneath the stone would demand forces that hundreds of workers pulling ropes couldn't generate, that thousands of persons working in coordination might accomplish, but whose organization would require communication and logistics capabilities that seem implausible for cultures whose social organization conventional archaeology characterizes as relatively simple. And Puma Punku isn't located on level ground, sits instead at 12,800 feet elevation, requiring that quarried stones be transported uphill through terrain where maintaining sufficient traction for effective pulling would be problematic. The route from Lake Titicaca quarries to Puma Punku involves steep inclines, include sections where gradients would make uphill transport of massive stones extraordinarily difficult even with modern equipment, presents obstacles that log rollers and rope pulling teams would struggle to overcome regardless of how many workers participated. Engineers familiar with moving heavy loads recognize that inclines multiply difficulty exponentially, that each degree of slope increases the force required by factors that quickly exceed what human muscle power can provide, that attempting to haul 131 tons up mountain grades using ancient methods would result either in failure or would demand workforce sizes and organizational sophistication that evidence doesn't support. The oxygen deprivation at altitude compounds transportation challenges, makes physical labor significantly more demanding than work at sea level, reduces human capacity for sustained exertion in ways that conventional explanations rarely address. Modern visitors to Puma Punku struggle with simple walking at this elevation, find themselves gasping after climbing stairs, discover that ordinary activities require frequent rest periods allowing bodies to compensate for reduced oxygen availability. Ancient workers hauling massive stones would face even greater challenges, would need rest periods so frequent that actual progress would be measured in meters per day rather than kilometers, would require support systems providing food, water, and shelter for teams whose size would number in thousands if sufficient force was to be generated. The absence of evidence for such massive workforce mobilization troubles researchers who examine the archaeological records seeking confirmation for conventional explanations. Moving 131-ton blocks using methods that experimental archaeology suggests are possible would require organizational infrastructure leaving traces in the archaeological record, would generate debris from rope manufacture and maintenance, would create living sites for workers whose presence over extended periods would produce pottery, tools, and organic remains that excavation should recover. Puma Punku's surroundings show no such evidence, reveal no worker camps, contain no debris suggesting massive construction projects employing thousands of laborers over months or years required to transport quarried stones across such distances. The water transport hypothesis, that alternative suggesting blocks were moved by raft across Lake Titicaca before final overland journey to the plateau, presents its own impossibilities that physics makes unavoidable. A 131-ton stone requires buoyancy that wooden rafts struggle to provide, demands construction so substantial that building it would be major project itself, needs stability that, preventing capsizing would be extraordinarily difficult to achieve especially on lake waters that can become rough with minimal warning. The raft would need to be enormous, would require quantities of timber that highland Bolivia doesn't naturally provide, would demand lashing and construction techniques producing watercraft capable of carrying loads that even modern barges find challenging. Lake Titicaca, despite being one of South America's largest lakes, sits at 12,507 feet elevation, experiences weather patterns that create dangerous conditions with little warning, presents navigation challenges that would make transporting massive stones by raft extraordinarily risky. Modern vessels equipped with engines and navigation instruments cross these waters carefully, respect the lake's ability to generate conditions that even powered craft find threatening, avoid attempting operations during periods when wind and waves make safe passage uncertain. ancient rafts carrying 131-ton stones would be even more vulnerable, would lack ability to maneuver effectively, would risk catastrophic loss if weather deteriorated during crossing. The landing sites where stone-laden rafts would beach themselves present additional challenges, require shallow approaches where vessels can ground safely, demand solid footing where unloading can occur without raft sinking into soft lakeside sediments, need conditions that Lake Titicaca's shores don't consistently provide. Getting a 131-ton stone off a raft onto solid ground would require ramps or cranes or techniques that conventional archaeology struggles to document, would generate physical evidence that excavation should recover if such operations actually occurred, would leave traces that researchers examining lakeside areas should detect if massive stones were regularly loaded and unloaded at specific locations. The chemical analysis confirming that red sandstone blocks came from specific quarries near Lake Titicaca, while andesite blocks originated from Copacabana Peninsula 90 kilometers away, proves beyond dispute that long-distance transport occurred, demonstrates that builders possessed capabilities for moving massive stones across significant distances despite challenges that modern engineering recognizes as substantial. The confirmation validates ancient achievement while deepening mystery about methodology, proves that transport happened while failing to explain how it was accomplished, creates situation where evidence demands capabilities that conventional tools and methods seem inadequate to provide. The modern attempts to replicate ancient stone transport using period-appropriate methods have demonstrated that moving multi-ton blocks is possible but extraordinarily difficult, that achieving distances of even kilometers requires weeks of effort by large teams, that attempting to move stones weighing over 100 tons using ancient methods fails or requires resources exceeding what Bronze Age cultures could plausibly marshal. These experiments aren't definitive proof that ancient peoples couldn't move massive stones, but they do demonstrate that conventional explanations involving log rollers and rope-pulling teams face serious practical obstacles that theoretical discussions tend to minimize. The quarry problem thus remains unsolved, continues challenging researchers seeking to understand Puma Punku's construction, forces uncomfortable questions about what capabilities ancient builders possessed. The blocks came from distant sources, arrived at altitude locations, were positioned precisely despite weighing masses that modern equipment finds challenging. The evidence proves achievement while methodology remains mysterious, demonstrates ancient capabilities while conventional explanations struggle, creates puzzle that 100 years of archaeology hasn't definitively resolved. The andesite blocks at Puma Punku present perhaps the most troubling aspect of the entire site, force confrontation with physical impossibilities that conventional tool explanation simply cannot address, demonstrate that whoever carved these stones possessed capabilities exceeding what Bronze Age technology should enable. Andesite registers 7 on the Mohs hardness scale, places it among volcanic rocks that resist conventional cutting methods, creates material that modern stone workers recognize as extraordinarily difficult even with diamond-tipped tools and power equipment. To understand the problem, one must grasp how Mohs scale functions, what hardness ratings actually mean, why materials softer than the stone being worked cannot effectively cut or shape that stone. The scale measures resistance to scratching, defines hierarchy where harder materials can scratch softer ones but not vice versa, establishes physical limitations that no amount of determination or skill can overcome. Copper, the metal that conventional archaeology insists was the hardest material available to Puma Punku's builders, registers only 3.5 on Mohs scale, creates tools that andesite would dull instantly, produces implements that would wear away faster than the stone they supposedly shaped. Bronze, that copper-tin alloy that represents metallurgical advancement beyond pure copper, reaches perhaps 4.5 on Mohs scale depending on precise composition, still falls dramatically short of andesite 7, remains inadequate for cutting or shaping, volcanic rock that resists everything softer than corundum or diamond. The mathematics are straightforward, reflect physical principles that cultural determination cannot override, establish that working andesite requires tools harder than the stone itself or alternative methods that don't rely on direct mechanical abrasion between tool and workpiece. The precision visible on andesite surfaces compounds the impossibility, proves that whoever worked this stone didn't merely scratch or chip it through patient application of inadequate tools, achieved instead the flat planes and sharp edges that grinding or polishing can produce only when abrasives harder than the material being finished are available. Modern stone workers use diamond-impregnated pads for polishing andesite, employ silicon carbide or aluminum oxide abrasives for achieving smooth finishes, recognize that creating mirror-like surfaces on hard volcanic rock requires materials and techniques that Bronze Age cultures supposedly didn't possess. The drill holes piercing andesite blocks at Puma Punku demonstrate capabilities that hand drilling using copper or bronze simply cannot achieve, show perfectly circular profiles maintaining uniform diameter through inches of stone harder than the tools supposedly creating them. Modern drilling of andesite employs diamond-tipped bits rotating at high speeds, uses water cooling to prevent overheating, requires steady mechanical pressure that human strength cannot maintain consistently enough to produce the uniform holes that Puma Punku displays. Attempting to drill andesite with copper or bronze produces only frustration, creates tools that deform or break without making appreciable progress, proves through direct experiment that conventional explanations don't work when tested against physical reality. The tool marks visible on some andesite surfaces, those parallel grooves that indicate cutting or sawing processes, suggest implements capable of sustained action against hard stone, imply manufacturing methods maintaining consistent depth and spacing across extended cutting operations. Modern stone saws use diamond-impregnated blades rotating rapidly, employ water jets to cool and lubricate cutting surfaces, generate forces that human-powered tools cannot replicate. The marks at Puma Punku show characteristics consistent with mechanical sawing rather than hand carving, display uniformity suggesting template-guided processes rather than freehand work. The absence of recovered tools compounds the mystery, eliminates physical evidence that might explain methodology, removes artifacts that would demonstrate what implements ancient workers employed. Extensive excavation at Puma Punku and surrounding Tiwanaku sites has failed to recover the stoneworking tools that conventional explanations require, hasn't discovered the copper or bronze implement supposedly used for carving andesite, produces archaeological record that doesn't support narratives about patient handwork using simple tools. The absence isn't merely lack of complete tool collections, represents instead total failure to recover even fragmentary evidence of implements capable of working andesite to observed precision. Some researchers propose that harder stones like diorite or obsidian provided tools sufficient for working andesite, suggest that indigenous peoples possess stone implements harder than volcanic rock they shaped, attempt to explain precision through patient grinding, using abrasive techniques. These proposals face their own problems, require that harder stones be available in quantity sufficient for sustained work, demand that tools themselves would leave marks or fragments that excavation should recover, assume that stone-on-stone grinding can achieve precision that modern experience suggests requires more sophisticated methods. The experimental attempts to replicate Puma Punku's stoneworking using period-appropriate tools have demonstrated that achieving even crude approximations of observed precision requires time investments that seem implausible, produces results that don't match quality visible at the site, proves that conventional explanations struggle when confronted with necessity of actually accomplishing what they theoretically propose. Researchers attempting to create flat andesite surfaces using stone hammers and sand abrasives report that progress is measurable in millimeters per day, that achieving truly flat planes requires specialized skills that take years to develop, that duplicating Puma Punku's precision using ancient methods would consume lifetimes even for master craftsmen. The alternative explanations, those proposals suggesting advanced technologies lost to later periods face their own credibility challenges but at least address the physical impossibilities that conventional theories ignore. Ultrasonic machining, that modern technique using high-frequency vibrations to shape hard materials, could theoretically produce Puma Punku's precision without requiring tools harder than the andesite being worked. Water jet cutting, that contemporary method employing pressurized streams containing abrasive particles, might achieve observed results without leaving tool marks that conventional cutting would generate. Chemical softening, that speculative process suggesting substances that temporarily reduce stone hardness, could explain precision while accounting for absence of recovered tools. Each alternative requires accepting that Bronze Age cultures possessed knowledge that later periods lost, demands acknowledgement that technological development doesn't always proceed linearly, from primitive to sophisticated, forces confrontation with possibility that ancient peoples understood principles that modern science has only recently rediscovered or hasn't yet recognized. The resistance to considering such alternatives reflects institutional investment in conventional narratives, demonstrates how academic careers built on established chronologies create incentives against accepting evidence that would require paradigm shifts, reveals that archaeological interpretation involves political and professional considerations alongside purely scientific evaluation of physical evidence. The andesite blocks stand as testimony to capabilities that conventional archaeology struggles to explain, demonstrate achievements that simple tools cannot replicate, prove that ancient stoneworkers possessed knowledge exceeding what established chronologies acknowledge. Whether that knowledge involved harder materials that evidence hasn't preserved, alternative techniques that physical principles permit but that conventional explanations don't propose, or capabilities inherited from earlier cultures about which history preserves only mythological memories, remains uncertain. What cannot be disputed is that the precision exists, that measurements confirm capabilities matching or exceeding what modern equipment achieves, that attempting to explain Puma Punku's stoneworking using conventional Bronze Age tools produces theories that experiments demonstrate don't work when actually tested against resistant volcanic rock that refuses to yield to implements softer than itself. The drill holes scattered throughout Puma Punku's stone blocks present mysteries that conventional tool explanations struggle to address, demonstrate capabilities that hand drilling using ancient implements shouldn't achieve, provide evidence that whoever worked these stones possessed techniques exceeding what Bronze Age technology should enable. The holes aren't crude punctures created through patient pecking with stone tools, aren't irregular openings showing the wandering that manual drilling inevitably produces, are instead perfectly circular profiles maintaining uniform diameter through inches of andesite harder than any copper or bronze bit that could create them. Modern machinists examining these holes recognize characteristics consistent with mechanical drilling, observe uniformity suggesting guided equipment rather than freehand work, note precision matching what contemporary drill presses achieve using hardened steel bits rotating at controlled speeds. The holes maintain consistent diameter from entrance to exit, show no deviation that would indicate operator fatigue or tool wear, demonstrate control requiring either mechanical guidance or capabilities that human steadiness alone cannot provide regardless of skill or experience. The perfectly circular profiles trouble researchers familiar with how ancient drilling supposedly worked, contradict expectations about results that stone or copper tools would produce, force questions about methodology that archaeological consensus doesn't adequately answer. Hand drilling using bow drills or pump drills, those techniques that experimental archaeology demonstrates ancient peoples employed, generates holes that wander slightly, that show irregularities reflecting variations in pressure and angle, that reveal operator influence through subtle imperfections accumulating as drilling progresses. Puma Punku's holes show none of these characteristics, exhibit instead the uniformity that mechanical processes generate, suggest either that guidance systems maintained alignment or that drilling methods differed fundamentally from what conventional archaeology proposes. the depth of some holes, extending several inches into andesite measuring 7 on Mohs hardness scale, raises questions about how long drilling would require using ancient methods, whether achieving such penetration with copper or bronze tools is practically feasible, how many bits would wear away before reaching full depth. Modern experience drilling andesite using diamond-tipped bits provides reference point, demonstrates that, even with contemporary equipment, progress is measured in minutes per inch, that cutting through volcanic rock this hard demands both appropriate tools and sustained mechanical pressure that hand-powered methods struggle to maintain. Experimental attempts to replicate Puma Punku's drill holes using period-appropriate tools have produced disappointing results, demonstrated that achieving comparable precision requires time investments exceeding what seems reasonable, proved that copper or bronze bits dull so rapidly that drilling even shallow holes demands constant bit replacement. Researchers attempting these experiments report that andesite's hardness defeats conventional drilling attempts, that bits deform rather than cutting stone, that progress is barely measurable even after hours of sustained effort by experienced operators using optimal techniques. The uniformity across multiple holes compounds the mystery, indicates that production methods maintained consistent results across numerous operations, suggests manufacturing approach rather than custom handwork producing unique outcomes each time. If each hole represented individual drilling operation requiring hours or days of patient work, variations between holes would be inevitable. Each would show characteristics reflecting specific circumstances of its creation. Differences would accumulate, making standardization impossible. Yet Puma Punku's holes show remarkable consistency, demonstrate repeatability, suggesting template-guided processes or manufacturing systems maintaining quality control across production runs. Some holes are precisely positioned relative to each other, arranged in geometric patterns suggesting careful measurement determined placement, demonstrating coordination between multiple drilling operations that required either templates or detailed planning ensuring accuracy. The spacing isn't random, doesn't reflect casual placement, follows exact layouts indicating that whoever created these holes understood geometric principles, possessed measurement capabilities ensuring precision, employed methods that modern manufacturing would recognize as systematic rather than improvised. The absence of partially completed holes, those abandoned drilling attempts that experimental archaeology consistently produces when replicating ancient stoneworking, suggests that Puma Punku's builders possessed confidence in their methods, knew that drilling operations would succeed, worked with techniques reliable enough that failures requiring abandonment didn't occur. Modern experimental drilling using ancient tools frequently fails, produces holes that wander unacceptably or that can't be completed because bits wear away faster than progress accumulates, leaves evidence of attempts that didn't achieve desired results. Puma Punku shows no such failures, exhibits only completed holes meeting exacting standards, implies mastery that experimental replication hasn't achieved. The drill holes in H blocks present additional puzzles, demonstrate that drilling occurred after blocks received their complex three-dimensional profiles, prove that access to drilling locations required maneuvering equipment around finished geometry creating awkward working angles. Some holes penetrate surfaces that would be difficult to reach using bow drills or similar hand-powered equipment, require drilling at angles where maintaining steady pressure and consistent rotation would challenge even experienced operators, suggest either that tooling could access confined spaces or that drilling occurred before final shaping, contrary to what tool mark sequences indicate. The perfectly circular cross-sections visible where holes intersect broken surfaces provide insight into drilling techniques, reveal characteristics that distinguish mechanical from manual processes, demonstrate uniformity extending throughout hole depth rather than being limited to entrance where careful initial positioning might explain precision. The circles remain perfect regardless of where breakage exposes them, show no degradation of accuracy as drilling progressed deeper into stone, prove that whoever created these holes maintained control throughout entire operation rather than achieving precision only in initial stages. Modern ultrasonic drilling, that contemporary technique using high-frequency vibrations to shape hard materials, produces holes remarkably similar to what Puma Punku displays, achieves precision through methods that don't require drill bits harder than material being worked, demonstrates that alternative technologies can accomplish what conventional mechanical drilling struggles to achieve. If ancient builders possessed ultrasonic capabilities, if they understood principles that modern industry rediscovered only recently, if they employed techniques that didn't rely on harder tools cutting softer materials but instead used vibration to disrupt molecular bonds, then the drill holes at Puma Punku become explicable through physics rather than remaining mysterious violations of what Bronze Age technology should accomplish. The proposal that ancient peoples possessed ultrasonic drilling capabilities strains credibility for researchers committed to gradualist narratives about technological development, contradicts assumptions about knowledge progressing linearly from simple to sophisticated, requires accepting that capabilities were lost rather than accumulated across generations. Yet the physical evidence demands explanation. The holes exist regardless of whether their creation fits comfortable chronologies. The precision is measurable independent of whether acknowledging it challenges established archaeological consensus. Either conventional explanations must account for how copper or bronze tools drilled perfect circular holes through andesite measuring 7 on Mohs hardness scale, or alternative proposals must be considered regardless of how uncomfortable their implications might be for disciplines invested in maintaining orthodox narratives about what ancient peoples could accomplish with tools that physics says shouldn't work but that somehow produce results that modern replication attempts consistently fail to duplicate. The drill holes thus remain as testimony, as physical evidence that whoever worked stone at Puma Punku possessed capabilities exceeding what conventional archaeology admits, as demonstration that ancient builders achieved precision matching modern standards despite supposedly lacking equipment that contemporary manufacturing requires for comparable results. The holes are perfectly circular, the diameters are uniform, the depths extend through material harder than tools that supposedly created them, and no amount of theoretical explanation about patient handwork using simple implements alters measurements that instruments confirm, that observations verify. That challenge assumptions forcing either revision of what Bronze Age cultures could accomplish or acknowledgement that someone at Puma Punku possessed knowledge that doesn't fit within chronological frameworks that mainstream archaeology has constructed and defended despite mounting evidence suggesting those frameworks inadequately describe capabilities that ancient stone workers demonstrated through precision that speaks louder than any academic consensus about what should or shouldn't have been possible when volcanic rock met drilling techniques that remain mysterious, that defy conventional explanation, that continue challenging researchers seeking to understand how perfectly circular holes penetrate andesite at Puma Punku, where mysteries accumulate faster than answers emerge. One of Puma Punku's most troubling mysteries isn't what exists at the site but rather what's conspicuously absent, what should be present if conventional explanations about stoneworking methods are accurate, what archaeological excavation consistently fails to discover despite extensive investigation across the plateau. The missing element is construction debris, those waste materials that stone cutting inevitably generates, the dust and chips and broken fragments that accumulate wherever hard rock is shaped using tools and abrasives. The absence isn't merely incomplete recovery of materials that once existed, represents instead complete lack of evidence for processes that supposedly consumed years or decades producing thousands of precisely shaped stone surfaces. Modern stoneworking provides useful reference point for understanding what Puma Punku should display if conventional tool explanations are correct. Cutting and shaping andesite generates substantial waste, creates dust that coats everything nearby, produces chips and fragments that scatter across work areas, leaves broken or worn-out tools that craftsmen discard after they become unusable. A major construction project working thousands of tons of volcanic rock would generate waste measuring in tons itself, would create debris fields that burial and weathering might diminish but couldn't eliminate entirely, would leave archaeological signatures that excavation should easily detect even after centuries of accumulation and erosion. Yet Puma Punku shows none of this expected evidence, exhibits cleanliness suggesting either that debris was meticulously removed after work completed or that stone processing occurred elsewhere with finished components transported to the plateau for final assembly. Either explanation raises uncomfortable questions about organizational sophistication, about resource allocation, about capabilities that Bronze Age cultures supposedly didn't possess. If debris was removed, where did it go? Why invest labor in cleaning construction sites when simply leaving waste materials would be far easier and when no functional reason for removal is apparent? If stoneworking occurred off-site, how were finished components transported across distances that moving raw blocks would be challenging enough without adding complexity of protecting precision surfaces during transit? The absence of stone dust, that fine powder that cutting and grinding inevitably produces, seems particularly significant because dust is difficult to completely remove, settles into crevices and depressions where casual cleaning wouldn't reach, creates deposits that weathering and burial preserve for archaeological recovery even after millennia. Modern stoneworking shops accumulate dust deposits measuring inches thick despite regular cleaning, demonstrate how pervasive this material becomes when hard rock is shaped using abrasive processes. Puma Punku should show similar accumulations if precision surfaces were achieved through grinding and polishing as conventional explanations suggest, yet archaeological investigation reveals no such deposits. The lack of broken or worn-out tools presents its own puzzle, eliminates physical evidence that would demonstrate what implements ancient workers employed, removes artifacts that might resolve debates about whether copper tools could actually shape andesite, regardless of theoretical arguments about hardness differences. Extensive excavation at Puma Punku and throughout surrounding Tiwanaku sites has recovered relatively few stoneworking tools, hasn't discovered the quantities of implements that major construction project would require, produces archaeological assemblages that don't match expectations about tool use if conventional explanations about patient handwork using simple equipment are accurate. The experimental attempts to replicate Puma Punku's precision using ancient tools demonstrate just how much waste would be generated and how many implements would be required. Researchers report that shaping even small areas of andesite surfaces produces substantial dust, breaks or dulls tools rapidly, creates debris that would be impossible to completely clean away using ancient methods. Scaling these observations to entire construction projects suggests that Puma Punku should be surrounded by waste deposits, should contain tool fragments numbering in thousands, should preserve evidence of manufacturing processes even if finished structures were later destroyed or removed. The absence forces either accepting that construction methods differed fundamentally from what experiments demonstrate or acknowledging that evidence removal was so complete that it eliminated traces that normal archaeological processes preserve. The alternative explanation, that stoneworking occurred at manufacturing facilities distant from Puma Punku itself, addresses debris absence while creating new mysteries about logistics and organization. If precision surfaces were achieved at quarries or specialized workshops, if finished components were transported to the plateau for assembly, if production was centralized while construction was distributed, then Puma Punku represents far more sophisticated organizational achievement than conventional archaeology attributes to Tiwanaku culture. Separating manufacturing from construction requires planning capabilities, transportation infrastructure, quality control systems ensuring that components produced at distant locations will fit properly when assembled, logistics that seem more characteristic of industrial rather than pre-industrial societies. This interpretation transforms Puma Punku from construction site into assembly location, from place where stone was worked into place where finished products were installed, from workshop into showroom displaying precision components manufactured elsewhere using methods that left no traces at final destination. If correct, the implication is that debris exists somewhere, that archaeological investigation at quarries or along transportation routes might discover waste deposits proving that stoneworking occurred but at locations other than where finished structures stood. However, no such discoveries have been reported despite decades of investigation, suggesting either that search hasn't been adequately conducted or that whatever processes created Puma Punku's precision didn't generate the waste that conventional stoneworking produces. The missing construction debris thus joins other Puma Punku mysteries in challenging conventional explanations, in forcing questions about what actually occurred at this site, in suggesting that orthodox archaeology's comfortable narratives about patient stoneworking using simple tools don't adequately account for physical evidence. The cleanliness isn't merely unusual, represents impossibility if standard construction methods applied, indicates either that removal capabilities exceeded what Bronze Age cultures should possess or that production methodologies differed fundamentally from what conventional interpretation proposes. Either alternative requires revising assumptions about ancient capabilities, about technological sophistication, about knowledge that supposedly didn't exist when Puma Punku was built. The absence also eliminates opportunities for resolving debates through physical analysis, prevents researchers from examining actual tools and debris to determine definitively what methods were employed, removes evidence that might distinguish between competing theories about whether conventional or alternative explanations better account for observed precision. This absence seems almost convenient for maintaining ambiguity, for allowing interpretations to remain contested, for ensuring that questions continue without definitive answers emerging through straightforward examination of materials that should exist but don't, that ought to be recoverable but aren't, that conventional archaeology expects but hasn't found despite looking extensively. And so the mystery deepens, the puzzle gains another impossible element, the challenge to orthodox interpretation accumulates additional evidence suggesting that something about conventional explanations doesn't fit physical reality that Puma Punku presents. The stones are precisely cut, the surfaces are impossibly flat, the drill holes are perfectly circular, and yet no debris remains, no tools survive, no waste deposits mark locations where such precision should have generated substantial byproducts if achieved through methods that experiments demonstrate ancient implements could theoretically employ if given sufficient time and skilled operators and ideal conditions that real-world construction rarely provides but that theoretical discussions assume obtain continuously across years or decades of sustained effort. That left no traces except finished products displaying capabilities that modern replication attempts consistently fail to duplicate despite advantages of documented techniques and purpose-built experimental protocols designed specifically to succeed where ancient workers supposedly triumphed using far less sophisticated approaches that nevertheless achieved results that contemporary stoneworking recognizes as remarkable even by standards of industry equipped with diamond tools and computer-guided equipment and all advantages that modern technology provides yet still struggles to match precision that exists at Puma Punku where absence speaks as loudly as presence, where what's missing tells stories as compelling as what remains, where debris that should exist but doesn't forces questions that comfortable answers don't adequately address, about what really happened on Bolivia's Altiplano when stones received precision that shouldn't exist and then somehow managed not to leave behind the evidence that achieving such precision should inevitably generate. The conventional dating of Puma Punku places its construction around 500 to 600 AD during the Tiwanaku civilization's peak, bases this chronology on radiocarbon analysis of organic materials found in association with the site, relies on pottery styles and cultural artifacts that mainstream archaeology assigns to this period. This dating aligns comfortably with established narratives about Andean cultural development, fits within frameworks describing how complex societies emerged in pre-Columbian South America, supports interpretations that attribute Puma Punku to indigenous achievement using technologies consistent with what other contemporary cultures possessed. But alternative dating proposed by researcher Arthur Poznansky, based on archaeoastronomical alignments and geological considerations, suggests the site might be far older than conventional chronology admits, possibly extending back to 15,000 BC or even earlier, predating not just the Inca and Tiwanaku civilizations but Egyptian pyramids, Mesopotamian ziggurats, essentially all monuments that mainstream archaeology recognizes as representing early advanced construction. Poznański's conclusions, developed through decades of study culminating in his 4-volume work published in the 1940s, challenged orthodox chronologies so dramatically that academic establishment largely dismissed his findings without seriously engaging the evidence he presented. Poznański's methodology focused on astronomical alignments, on how Puma Punku's structures related to celestial phenomena, on using those relationships to determine when buildings were oriented toward positions that sun, moon, and stars occupied during construction. The technique, called archaeoastronomy, works from principle that ancient builders often aligned monuments with astronomical events, that these alignments reflected sky positions at construction time, that calculating when alignments were accurate provides dating independent of radiocarbon or artifact analysis. The method has limitations, depends on assumptions about builders' intentions and capabilities, requires complex calculations involving Earth's axial, precession and orbital variations, produces results that mainstream archaeology often views skeptically, especially when they contradict established chronologies. Poznański measured angles between structures and calculated what stellar configurations would produce observed orientations, determined that alignments matched sky positions from approximately 15,000 BC, proposed that this dating better explained various geological and architectural features than conventional 500 AD chronology could. His work wasn't casual speculation, involved detailed surveying and mathematical analysis, produced specific calculations that other researchers could verify or challenge, represented serious attempts to determine Puma Punku's age through methods that didn't rely on potentially contaminated radiocarbon samples or debatable cultural associations with pottery styles and artifact assemblages. The mainstream rejection of Poznański's conclusions reflects partly legitimate concerns about archaeoastronomical methodologies' reliability, acknowledges that ancient builders didn't necessarily prioritize astronomical alignments as Poznański assumed, recognizes that multiple sky configurations could produce similar ground orientations, making definitive dating difficult. But rejection also reflects institutional resistance to accepting dates that would require fundamental revision of Andean chronologies, that would challenge comfortable narratives about how civilizations developed, that would force acknowledging that advanced construction capabilities existed far earlier than orthodox frameworks admit, potentially predating agricultural development and settled societies that conventional archaeology considers prerequisites for monumental architecture. The geological evidence that Poznański cited in support of ancient dating included weathering patterns, erosion characteristics, soil stratification, suggesting the site had been exposed to environmental conditions for far longer than 1,500 years. He noted that stone surfaces showed deterioration consistent with extended exposure to high-altitude climate, that buried portions displayed preservation suggesting they'd been protected from weathering for millennia, that overall condition implied age exceeding what conventional dating allowed. Mainstream archaeology responded that weathering rates are difficult to determine precisely, that local conditions can accelerate or decelerate erosion unpredictably, that appearance alone can't reliably indicate age without understanding complex environmental factors affecting preservation. The debate about Puma Punku's age connects to larger controversies about human prehistory, about whether advanced civilizations existed before currently recognized earliest developments, about whether catastrophic events like the Younger Dryas impact might have destroyed evidence of earlier cultures, leaving only scattered monuments testifying to capabilities that later peoples couldn't replicate. If Puma Punku dates to 15,000 BC, if its precision required sophisticated knowledge that supposedly didn't exist At that time, if construction capabilities demonstrated at the site predate agricultural revolution and settled societies by thousands of years, then fundamental assumptions about cultural development require revision, orthodox chronologies become inadequate. Comfortable narratives about gradual progress from simple to complex must accommodate evidence of advanced achievement at unexpected early dates. The 17,000-year chronology remains controversial, hasn't gained acceptance within mainstream archaeology, continues being dismissed by orthodox scholars who maintain that radiocarbon dating and cultural associations provide reliable 500 AD construction date. But the astronomical evidence Poznański documented hasn't been definitively refuted. The geological observations he recorded remain valid even if their interpretation is debated. The possibility that Puma Punku might be far older than conventional dating admits, continues troubling researchers who recognize that precision stoneworking at the site exceeds what Bronze Age cultures should accomplish, regardless of when that accomplishment actually occurred. Whether dating proves to be 1,500 years ago or 17,000 years ago, the engineering remains remarkable, the precision demands explanation. The capabilities demonstrated require accounting for through some narrative that acknowledges ancient achievement even if uncertainty persists about exactly when that achievement occurred on Bolivia's Altiplano, where astronomical alignments encode information about construction dates that conventional and alternative chronologies interpret differently, while agreeing that whatever age proves correct, Puma Punku represents extraordinary accomplishment by builders whose knowledge exceeded what their supposed technological limitations should have enabled. The condition of Puma Punku today doesn't reflect gradual decay through centuries of weathering and neglect, doesn't show patterns consistent with slow deterioration that time inevitably produces, suggests instead violent catastrophic event that shattered structures, scattered massive stones, reduced what must have been sophisticated architecture to chaotic jumble of broken blocks that archaeologists struggle to interpret. The destruction wasn't orderly collapse, wasn't methodical dismantling by later people seeking construction materials, was sudden catastrophic force that treated 100-ton andesite blocks like toys, throwing them across the site, burying some completely while leaving others precariously balanced, creating disorder that 17 centuries of weathering alone cannot explain. The scattered distribution of blocks defies conventional explanations about earthquake damage or gradual structural failure, shows patterns more consistent with tsunami or massive flood that picked up stones and relocated them, that generated forces capable of moving masses that normal geological processes struggle to displace. Some blocks lie hundreds of meters from where they presumably originated, transported distances that earthquakes don't accomplish, positioned at angles suggesting they tumbled rather than simply fell from original locations. The random orientations, the burial depths, the overall chaos, all indicate forces far exceeding what normal decay produces, forces that conventional archaeology struggles to identify through known historical events. The evidence of rapid burial, that characteristic where some blocks remain partially exposed while others disappeared completely beneath accumulated sediments, suggests flooding that deposited material quickly rather than erosion that accumulates gradually over centuries. Some stones show clean breaks exposing fresh andesite surfaces, suggesting fractures occurred during catastrophe rather than through slow weathering that would have rounded edges and coated broken surfaces with patina accumulated across centuries. The freshness of breaks, the positions of fragments, the distribution patterns, all indicate that destruction was sudden, violent, comprehensive, that whatever happened at Puma Punku shattered structures, with force exceeding what earthquakes or gradual collapse generate. The geological context surrounding Puma Punku supports catastrophic flooding hypothesis, reveals landscape features consistent with massive water flows, shows sediment deposits matching what tsunami or megaflood would leave behind. Lake Titicaca sits approximately 10 kilometers away at lower elevation, creates potential water source that earthquake-triggered sloshing or dam failure could release with devastating effect. The intervening terrain shows evidence of high water marks, reveals erosion patterns suggesting powerful flows, contains sediments whose characteristics match what catastrophic flooding deposits when water velocities exceed normal stream flow capacities. The Younger Dryas impact hypothesis, that theory proposing comet fragments struck Earth approximately 12,900 years ago, triggering catastrophic climate change and megafloods worldwide, provides possible explanation for Puma Punku's destruction if the site dates to periods preceding this event. Evidence for Younger Dryas impacts includes widespread fire layers, sudden climate shifts, extinction of numerous megafauna species, geological markers suggesting extraterrestrial materials deposited globally during narrow time window. If impacts generated massive flooding through melting ice sheets, if South America experienced tsunami-scale inundations, if Puma Punku existed when these catastrophes occurred, then current condition might reflect destruction from events whose scale dwarfed anything historical records preserve. The alternative dating suggesting Puma Punku might be 15,000 to 17,000 years old places construction before Younger Dryas impacts implies that destruction could have resulted from catastrophes that eliminated numerous advanced cultures worldwide, that scattered survivors who preserved fragmentary memories encoded in flood myths ubiquitous across human traditions. The alignment of catastrophic destruction evidence with alternative chronology suggesting greater antiquity creates narrative where Puma Punku represents pre-cataclysm achievement, demonstrates capabilities that later cultures couldn't replicate, preserves, in scattered broken stones testimony to knowledge that disaster destroyed so completely that subsequent peoples inherited only ruins without understanding what had been lost. The absence of skeletal remains, that puzzling lack of human bones that major catastrophe should produce if settlement was occupied when destruction occurred, suggests either that site was abandoned before disaster struck or that whatever happened removed organic materials so thoroughly that normal archaeological preservation failed. Catastrophic flooding can transport bodies considerable distances, can scatter remains so widely that recovery becomes improbable, can bury materials under sediments that later excavation doesn't penetrate. The absence doesn't prove site was unoccupied but does indicate that if people were present during catastrophe, evidence of their presence hasn't survived in forms that excavation typically recovers. The broken precision surfaces, those shattered blocks exposing internal structure showing that entire thickness maintained quality rather than being limited to exposed faces, demonstrate that destruction fractured components whose manufacture had been extraordinarily difficult, that catastrophe didn't discriminate between ordinary and exceptional work, that whatever forces operated treated irreplaceable precision stonework as casually as they treated crude rubble. The breaks expose drilling holes, reveal internal geometries, show construction details that intact surfaces concealed, provide information that wouldn't be available if catastrophe hadn't shattered blocks revealing their internal character. The modern attempts to reconstruct Puma Punku's original configuration face challenges that scattered broken condition creates, struggle to determine which blocks originally connected, can only speculate about how components fit together when so much is missing, and when surviving pieces lie scattered across site without clear indication of original positions. Archaeological reconstruction depends on finding patterns, on identifying how pieces relate, on using surviving elements to infer missing ones. Puma Punku's condition defeats these methods, presents puzzle where too many pieces are missing, where surviving fragments don't clearly indicate original arrangements, where violence of destruction scrambled evidence so thoroughly that definitive reconstruction becomes impossible without speculative assumptions that cannot be verified. The catastrophic destruction thus compounds mysteries that Puma Punku already presented through its precision alone, adds uncertainty about original form to questions about construction methods, ensures that understanding what existed before catastrophe requires interpreting fragmentary evidence that violent forces rendered ambiguous. The stones testify to capabilities, the precision demonstrates knowledge, the scale implies organization, but original purposes remain mysterious, because structures that would have revealed functions through their complete forms exist now only as scattered broken pieces that suggest magnificence without clearly documenting what that magnificence was designed to accomplish when Puma Punku stood intact, before forces shattered it, scattered it, reduced sophisticated architecture to chaos. That centuries haven't clarified, that excavation hasn't resolved. That researchers examining scattered stones can only speculate about while recognizing that, whatever catastrophe struck this site possessed violence exceeding what normal historical events generate, force matching what only rare extraordinary disasters produce, scale consistent with events that geological record preserves but that human memory maintains primarily through myths describing floods and catastrophes and destructions that wiped away earlier worlds leaving only fragments, testifying that something remarkable existed before catastrophe transformed achievement into enigma, precision into mystery, engineering into scattered broken stones that raise more questions than they answer about what Puma Punku was before violence destroyed what builders had created through capabilities that even destruction couldn't eliminate, from surfaces still precise despite being broken. The ultimate test of any theory about ancient construction methods comes not from academic arguments or theoretical calculations, but from actual attempts to replicate achievements using tools and techniques that conventional explanations propose ancient builders employed. If copper chisels and stone hammers could shape andesite to Puma Punku's precision, if patient handwork over extended periods could achieve observed flatness, if Bronze Age capabilities were adequate for creating what visitors see scattered across the plateau, then modern replication using identical methods should succeed even if requiring substantial time and effort. The attempts have been made, the experiments have been conducted, the results speak clearly about gaps between what theory proposes and what practice achieves. In 2012, a team of researchers and skilled stone workers attempted to replicate one of Puma Punku's simpler H-blocks using only tools that Bronze Age cultures supposedly possessed, working under conditions approximating what ancient builders would have faced, attempting to demonstrate that precision stoneworking could be accomplished through determination and skill without requiring advanced technology or mysterious lost knowledge. The team included experienced stonemasons, individuals whose professional expertise involved shaping rock, who understood how materials behave and what techniques produce specific results, who brought practical knowledge that armchair theorists lack regardless of academic credentials. The replication attempt began optimistically, with team members confident that careful work using proper techniques would prove conventional explanations correct, that patient application of appropriate methods would duplicate ancient achievements, that mystery surrounding Puma Punku reflected more ignorance about ancient capabilities than any genuine technological impossibilities. But optimism faded as work progressed, as tools broke or dulled faster than stone yielded, as hours of effort produced minimal progress toward creating surfaces approaching Puma Punku's flatness, as the gap between theoretical possibility and practical reality became undeniably apparent through direct physical confrontation with resistant volcanic rock. The first challenge involved simply removing material, reducing raw andesite block to approximate desired dimensions before attempting precision finishing. Even this preliminary work proved extraordinarily difficult, with copper tools deforming rather than cutting stone, with hammering techniques producing fractures rather than controlled shaping, with progress measured in millimeters per day rather than centimeters per hour, that practical construction would require. The team adjusted techniques, modified tools, experimented with different approaches, yet fundamental problem remained. Andesite's hardness exceeded capabilities of implements that conventional archaeology insisted were adequate. After 6 months of sustained effort, the team had produced rough approximation of H-block shape but hadn't approached precision that Puma Punku displays, had created surfaces showing irregularities measurable in millimeters where originals varied by tenths of millimeters, had achieved right angles that were close but not exact where ancient examples showed geometric perfection. The attempt demonstrated that replicating even crude version of Puma Punku's precision using Bronze Age tools required time, investment that seems implausible for major construction project, that finishing to observed standards would demand additional months or years of work per block, that achieving site-wide consistency would require organizational capabilities and resource allocation exceeding what conventional narratives attribute to indigenous South American cultures. The 2018 laser cutting experiments provided different perspective, testing whether modern precision equipment could match Puma Punku's surfaces, determining what contemporary technology required for duplicating ancient achievement. Industrial laser cutting systems, representing sophisticated manufacturing capabilities unavailable to Bronze Age builders but useful for establishing baselines about what precision demands, were employed to shape andesite samples matching composition of Puma Punku blocks. The lasers succeeded in creating flat surfaces and accurate angles, demonstrated that contemporary equipment could duplicate ancient precision, but the process required 40 hours of continuous operation for single modest-sized surface. Scaling these results to Puma Punku's extent, where thousands of precision surfaces exist across hundreds of blocks scattered throughout the site, suggests that even with laser technology working continuously, the project would require years of equipment operation, would consume enormous energy, would demand resources that seem impossible for pre-industrial society. If modern lasers need 40 hours per surface, if ancient builders achieved identical results using supposedly simple tools, then either conventional explanations dramatically underestimate ancient capabilities or alternative theories proposing lost advanced knowledge deserve serious consideration, despite how uncomfortable their implications might be for established chronologies. The drilling replication attempts faced similar challenges, demonstrated that creating Puma Punku's perfectly circular holes through andesite using copper or bronze implements isn't practically feasible regardless of theoretical arguments about patience and skill. Experimental archaeologists attempting to drill even shallow holes reported that bits deformed almost immediately upon contact with volcanic rock, that progress was barely measurable even after hours of sustained effort, that achieving depths matching Puma Punku's holes would require tool replacement so frequent that copper consumption would exceed what Bronze Age cultures could plausibly allocate to single construction project. The experiments proved that while drilling andesite with primitive tools isn't absolutely impossible, in theoretical sense, it's so impractical that proposing it as explanation for observed holes strains credibility beyond reasonable acceptance. Modern diamond core drilling of andesite provides useful comparison, demonstrates what appropriate tools achieve when properly matched to material being worked. Diamond bits cut through volcanic rock efficiently, create circular holes maintaining uniform diameter, produce results matching Puma Punku's precision without extraordinary difficulty. But diamond bits represent technology that conventional chronology insists wasn't available to ancient Andean builders, create problem where tools adequate for task didn't exist according to orthodox archaeology, while tools that supposedly did exist prove inadequate when actually tested against resistant stone. The replication failures don't absolutely prove that ancient builders possessed advanced technology, don't definitively establish that conventional explanations are wrong, but they do demonstrate that comfortable theories about patient handwork using simple tools face serious practical obstacles that theoretical discussions tend to minimize. The experiments show what happens when proposals must confront physical reality rather than remaining safely abstract, reveal gaps between what should work according to theory and what actually works when implements meet resistant materials, prove that achieving Puma Punku's precision using Bronze Age technology would require capabilities exceeding what replication attempts have demonstrated possible, despite modern advantages of documented techniques and purpose-designed experimental protocols. The consistent failure of replication efforts forces difficult questions about how ancient achievements were actually accomplished, challenges assumptions that conventional tools were adequate, suggests that either builders possessed knowledge about stoneworking that experiments haven't rediscovered or that technological capabilities exceeded what orthodox chronology admits. Neither alternative fits comfortably within established frameworks, both require revising accepted narratives, each demands acknowledging that mysteries surrounding Puma Punku aren't merely gaps in knowledge that future research will resolve but genuine puzzles indicating that current understanding of ancient capabilities remains inadequate despite decades of investigation. Despite experimental archaeology's best efforts, despite everything suggesting that stone surfaces scattered across Bolivia's Altiplano preserve evidence of achievement that modern technology struggles to duplicate and that Bronze Age tools apparently couldn't produce despite theoretical arguments proposing otherwise, despite academic consensus maintaining that conventional explanations remain adequate, despite mounting experimental evidence demonstrating that, when theory confronts practice at Puma Punku, practice consistently reveals that precision existing there exceeds what replication attempts using period-appropriate tools have successfully achieved. The fundamental question haunting Puma Punku, the mystery that refuses resolution despite decades of investigation, the puzzle that accumulates evidence faster than explanations emerge, centers on a simple but profound issue: what was this place really designed to accomplish? The conventional narrative describes religious temple, ceremonial center, spiritual complex serving the Tiwanaku civilization's cosmological requirements, architectural expression of indigenous beliefs about sacred geography and divine powers. But this interpretation struggles to account for precision that exceeds what religious architecture requires, for engineering sophistication that seems purposeless if structures served only symbolic functions, for capabilities demonstrating knowledge that spiritual motivations alone don't adequately explain. The evidence increasingly suggests that Puma Punku wasn't temple but facility, wasn't religious complex but functional infrastructure, wasn't spiritual architecture but technological installation serving purposes that stoneworking precision reflects but that conventional archaeology refuses to acknowledge, because accepting functionality would require revising comfortable narratives about what ancient peoples understood and what capabilities they possessed. The standardized components, those interchangeable H-blocks and modular elements showing manufacturing consistency, don't characterize religious architecture where symbolic uniqueness typically takes precedence over functional uniformity, where each element embodies specific meanings rather than serving as replaceable part in larger system. Modern manufacturing employs standardization for practical reasons, creates interchangeable components enabling efficient assembly and maintenance, produces parts matching specifications that any compatible element can satisfy regardless of which specific piece gets installed. Religious architecture rarely employs such standardization, typically treats each element as unique expression, creates custom components whose meanings depend on their specific characteristics rather than on conforming to templates enabling interchange. Puma Punku standardization thus suggests manufacturing mindset rather than religious thinking, implies that builders prioritized functional requirements over symbolic expression, indicates that precision served practical purposes rather than merely demonstrating skill or impressing observers with architectural magnificence. The absence of decoration, that puzzling lack of hieroglyphs or religious imagery or any embellishment beyond functional geometry, reinforces interpretation that Puma Punku served technological rather than spiritual purposes. Every known religious structure from ancient world incorporated symbolic elements, displayed imagery reinforcing beliefs, covered surfaces with representations of deities or mythological narratives or ritual scenes. Temples without such decoration are essentially unknown in archaeological record because religious architecture's entire purpose involved creating sacred space through visual and symbolic elements communicating spiritual meanings. Puma Punku's blank surfaces suggest that decoration would have been inappropriate or counterproductive, that functions the facility served didn't benefit from religious imagery, that purposes were sufficiently clear through architecture itself that additional symbolic elaboration wasn't necessary. The precision itself provides clue about functions, indicates that tight tolerances served requirements that approximate accuracy couldn't satisfy, suggests that whatever processes occurred at Puma Punku demanded exact alignments and perfect fits that religious ceremonies wouldn't require. Modern precision manufacturing serves functional rather than aesthetic purposes, creates components whose tight tolerances enable machinery to operate reliably, produces parts whose specifications must be met, or systems fail regardless of how impressive approximate accuracy might appear. If Puma Punku required similar precision, if components needed exact geometry to function properly, if purposes the facility served depended on tolerances measured in tenths of millimeters, then describing it as temple or ceremonial center misses its actual nature as completely as calling modern factory a cathedral would mischaracterize industrial facility as religious architecture. The drill holes present throughout the site, those perfectly circular penetrations serving no obvious decorative purpose, suggest mechanical functions that conventional religious interpretation doesn't address. The holes aren't randomly positioned, follow patterns indicating systematic placement, occur in locations suggesting they accommodated components that no longer survive, imply that Puma Punku once incorporated elements made from materials that decay over millennia, leaving only stone frameworks still testifying to precision that installation required. If holes accommodated machinery, if they secured equipment whose operation demanded exact positioning, if they enabled processes requiring components whose precision matched what stonework demonstrates, then Puma Punku represents technological facility whose purposes remain mysterious only because perishable elements haven't survived, leaving archaeologists confronting stone infrastructure without understanding what systems it originally supported. The interlocking geometries, those three-dimensional profiles enabling blocks to connect through precise fit rather than through mortar or gravity, suggest construction methods anticipating disassembly and reassembly, imply that structures weren't meant to be permanent but rather modular systems that could be reconfigured as requirements changed. Modern industrial facilities employ similar approaches, create frameworks supporting equipment that might need replacement or modification, design infrastructure accommodating future changes without requiring complete reconstruction. If Puma Punku incorporated similar thinking, if precision served needs for reliable assembly and disassembly, if architecture reflected understanding that flexibility was valuable and that exact tolerances enabled modification without compromising structural integrity, then conventional interpretation, describing fixed religious architecture misses essential character, a facility designed for technological rather than spiritual purposes. The 2025 geopolymer theory, that proposal suggesting some blocks were cast rather than carved, provides alternative explanation for precision while reinforcing interpretation that Puma Punku represents technological achievement rather than merely impressive religious architecture. If ancient builders possessed knowledge about creating artificial stone through chemical processes, if they understood how to formulate mixtures producing rock-like materials that could be poured into molds generating perfect geometry automatically, if they employed manufacturing techniques that modern industry is only recently rediscovering, then precision becomes explicable through chemistry rather than remaining mysterious, achievement requiring unknown cutting technologies. The geopolymer hypothesis also explains absence of construction debris, accounts for how identical components could be produced efficiently, demonstrates that builders possessed sophisticated materials science knowledge that later periods lost when catastrophes disrupted cultural transmission of technical information. The catastrophic destruction that scattered Puma Punku's blocks, that violent event treating massive stones like toys and reducing sophisticated architecture to chaotic rubble, might have served another purpose beyond physical destruction, might have eliminated knowledge along with structures, might have ensured that whatever technologies the facility employed became impossible to reconstruct when survivors lacked both equipment and understanding necessary for recreating capabilities that infrastructure once enabled. If Puma Punku represented technological pinnacle, if it embodied knowledge that took generations to develop, if it served functions that later cultures couldn't understand, much less replicate, then its destruction represented not just architectural loss but technological catastrophe, eliminating capabilities that human societies wouldn't recover for millennia if they ever recovered them at all. The modern reluctance to investigate deeper, that pattern where authorities discourage excavation beneath visible remains despite radar suggesting substantial underground structures, mirrors suppression patterns visible at other ancient sites where discoveries threaten established narratives, where evidence challenges comfortable chronologies, where findings might force acknowledging that ancient peoples possess knowledge exceeding what orthodox archaeology admits. If underground chambers contain evidence proving technological interpretation, if deeper excavation would reveal facilities clearly designed for functional, rather than religious purposes, if investigation would demonstrate capabilities that Bronze Age cultures supposedly couldn't possess, then preventing such discoveries serves interests protecting orthodox narratives even at cost of leaving mysteries unresolved and questions unanswered. Puma Punku thus stands as testimony not just to ancient achievement but to modern denial, not merely as monument to forgotten capabilities but as demonstration of how institutions resist evidence threatening established frameworks, not simply as archaeological site but as battlefield where physical evidence confronts academic consensus and where consensus too often prevails despite measurements proving precision, despite experiments demonstrating conventional tools' inadequacy, despite everything suggesting that scattered stones preserve truths about human past that comfortable narratives can't accommodate without fundamental revision of who we were, what we knew, and what we lost when catastrophe destroyed not just architecture but entire technological civilizations whose scattered ruins testify to capabilities that modern replication attempts consistently fail to duplicate.